In this video, we take a look at the NCM Nippon Calculator. This, in fact, is one of the last models of mechanical calculator. So this is built like around 1970s, and not long after this model, these all became obsolete, and all of these companies that built mechanical calculators all went bankrupt. This is because the new calculators came in, the new electronic ones like the Sinclair, and once those came in, who would want a mechanical one? Well, even though electronic ones are nicer, nothing can beat how nice these are. If we take a look round to the back, sadly there that first label is a bit damaged. The one below is in Chinese, which is interesting. So let's now demonstrate this. Before we can demonstrate it, we've got to reset it. So reset number 1. Number 2 resetting is a weird one, because you have to put it down like that, then you release it, then you pull it just to halfway, then top one reset, you do that. So now let's do some addition. First we put our first number we want to add in, which let's make it that number. Turn the handle forwards for addition, and it's shown that's been added. Now we reset, all the pins jump back, put in our second number we want to add, which is going to be that number there. Let's add that, and that's the two numbers added together. Now let's move this across to show where the number starts. It starts there, and that's how we do addition. So now we're going to reset it. Pull that one to reset there, reset that one, reset to halfway, and reset the pins. Now it's going to be multiplication, but it is a problem. When I do this forwards, the multiplication row goes in twos. It should only show one. I do one turn, but it goes in twos. Something's wrong here. I don't know why it's wrong, but something's wrong. So we're going to have to work around it and just factor out the fact it's doing it in twos when it should do it in ones. That is just really weird. So we're going to do the number of 723 times 44. But because it's doing it in twos, we're going to have 88 there, because for some reason, I don't know why it's doubling it. It shouldn't do that. But anyway, 723 times 44. So we turn it 4 times. 1, 2, 3, 4. It shows 8 down there. Now we move the carriage along. So we move it along this way by 1. Now we do the same thing again. Turn it by 4. 1, 2, 3, 4. So that is 723 times 44 gives the answer of 31,812. Right then, I've demonstrated how to use it. Now it's time to demonstrate how it works. Now let's demonstrate how the pins work. The further you set the numbers, the more pins that come out. So the wheels in the first register get turned to the number you've set. And now I demonstrate the carry. Now I demonstrate the lookout between pin setting and pin turning. And now I demonstrate the lockout. If all of the levers are not in the correct position, it will not move. Now I demonstrate the reset. And now I'm going to demonstrate division. Now this machine can actually do division because it's got the subtraction flag. So to demonstrate the subtraction flag, I'm going to do is put in a big number, go forwards, so addition plus, that's forwards, and it goes plus 2. Now the big number's in there, now I'm going to reset that, and do a smaller number to subtract. Now I'm going down this time, subtracts down, and as I go down, watch what happens, it goes 2, but with a negative flag lit up. Now because of that, it's gone 2, which is the interesting bit. Now, that's actually negative 2. Now without this flag, so I'm going to demonstrate what most machines do. I don't have the flag. If I go forwards, setting the flag to positive, backwards, now when I go backwards again for subtraction, it goes 999. Now most machines, because they don't have a flag, will always be positive, meaning 999 lights up as I go backwards, meaning you can't do a division. But because of this flag, I can do a division. So let's now demonstrate how the division works. And now it's time to demonstrate division. So before we do anything, reset. Now let's bring our first number. Let's do a nice juicily big number. Let's do 65,449. So we're now going to do that into our first register. So we do add, put it in the register. Now we need to remember where the decimal place is. This is very important for division. So decimal place is there. That is our decimal place. Then we need to remember the decimal place for here. Now the bit here is missing. It must have fallen off at some point. But we have to remember that dot there. See that dot? That's going to be our decimal place. So we now reset this. So the negative flag will get set. So that register needs to be reset. Reset this. So we now put in the number we want to divide by. So we're going to do 65,449 divided by 255. Let's go. So we're going to go downwards for subtract, and we're going to go dividing, and this is how we divide. We keep subtracting to divide, but that's taking too long. So we now need to move our carriage along. The answer is appearing here, and as we move the carriage along, that moves along and the answer moves along. That's why I have to keep track of decimal places. Remember, that dot there is our decimal place, and that decimal place has been set by that. So now we've done that, we can now do that, and notice it's quicker now because we moved along by 10. And so keep going until it gets to 0, but then, ding! Oh dear, I've gone too far. It's gone ding. Right, I need to cancel out the ding by going back the other way. The ding's now been cancelled. That's good. So now we can move the carriage along by 1. Now we carry on. So we're back to the units, and we keep subtracting until again it will go ding. Cancel out our ding. So that's the dividing complete. But now we can do accuracy. Let's go into the decimal places. So now we're doing the tenths. Now we do the same thing again. Until we go ding, cancel our ding. Now we go along to do the hundredths. Now we do the hundredths. And as we do that, we're always trying to get this number closer and closer to 0. Ding, gone ding. So we have to then do the other way, cancel our ding. Now we're going to do the thousandths. So we go along by 1, and we're trying to get this number closer and closer to 0. So we're now doing the thousandths. Get numbers close as we can to 0. Ding, cancel the ding. Now we go along. We're now doing the 10 thousandths. So now we now get our number closer and closer to 0 again. Ding, cancel the ding. And I think that's close enough. We've got enough accuracy now. So now we can find our answer. And remember, we're doing that decimal place there. It's our decimal place. Now this number, sadly, is doubled because there's silly things doing it by 2s. I don't know why it's doing it by 2s, but the whole thing ends up being doubled. So the half of that is the answer. So to make up for the fact that the second register cranks over twice for each turn, let's divide the answer by 2, which gives 267.7738. Now I looked up the answer, and the actual answer is 256.6627. The machine got it wrong, and the reason why it got it wrong is there's some fault in the second register. The problem is that the second register turns over twice each time I crank a handle, which is wrong. There's a fault there. But when I overcranked it, so when it went ding when I went too far, then I had to go back to reset the ding. When I turned back, sometimes the second register wouldn't turn back as I went back. So it kept turning forwards by 2, but it would turn back by 0, meaning the the number just got out of sync. So sadly there's something wrong with the second register, but it's still a very epic calculator, and the first register is working completely correct. It's just the second one that's got the fault. Now this machine has another feature which I don't know what it does. So if we reset that, reset this, then reset that, that bit doesn't move, but when I reset, it does move. But what's that for? What's that doing? I don't get it. I think that's the unjamming feature, because when you pull that across, you've taken all the cogs out of alignment, so you can then, I think, turn it manually. So I think that's like an unjamming feature, which is nice to have. So that is the review of the Nippon Calculator, and that is the end of the video.